So I'm going to go straight on to example number 1. It says to construct a tangent to a circle at a point on the circle, meaning connect PQ, and then you'll make a line through just the one point Q. And I know we only need 2 points to make a line, but I want to go ahead and name this with, or make 2 more points. Let's call this one D. So going back to the lesson from the other day, tangent means it's at a what kind of angle?
Right.
It must be perpendicular at a right angle. And then I want you to circle something. Q is a point of tangency. Q is the point of tangency. So point of tangency at Q. Now, if I were to ask you to name the tangent line, you have to include the Q, because that is a point of tangency. So I can either call it AQ, so my tangent line is at AQ. How else can I name this? DQ. But you have to put the line above it, otherwise it's going to be not a tangent. What was the other one that we learned the other day that also had a line above it? Secant. Just a reminder. Okay, let's go straight to the bottom. Example number 2. Mark, let's read number 2. Find.
Oh. Find PQ if line QS is a tangent of circle P.
Perfect. Let's highlight the right triangle. Also notate the right angle. And we're looking for PQ. That's our X. So what theorem can I use to find PQ? Pythagorean, or we could take a shortcut and use something else. What is that? Triple. What triple is this? 5, 12, 13. So therefore, X must be 5. But if you forget, Pythagorean will always be available. All right, I want to change example number 3 just so that it's going to be very helpful for you on your next assessment. Cross this off. I'm going to say find X and Y. And you're like, where's the X and Y? So here I go. My X is a green. So all that is my X. And then my Y is going to be the pink. That piece is going to be the Y. Can we go ahead and put the right angle symbolic notation right here? Yeah. Which triple can I use on this one? 7, 24, 25. So we have 7, 24, 25. So we have the 7, we have the 24. That means our hypotenuse must be, so X equals 25. And then we have something unique about one circle. If I know CB is a radius of 7, isn't B to the edge also radius of 7?
Yes.
So given that, what will be the value of Y? 18, very good. Ooh, that's an 18. If you're good with that concept, give me a thumbs up. Because the radius will always be equivalent. So let's move on to the back and look at our definition. And Luke, let's read the theorem in the box.
Two circles are tangents to a circle from the same external point. The segments are indirect.
So we have 2 segments in a circle. So I want you to give me a circle. And we want a tangency, so put a dot wherever you want, and I'm going to call that AC. And put a dot outside of the circle, let's call that B. So if I go ahead and connect BA and BC, do I have 2 tangent points? One on A and one on C. As long as that happens, there's a fact that's going to happen every single time. We know AB will always be congruent to, what do you think? CB. So we have AB will always be congruent to CB. For me, I see like an ice cream cone with a spherical ice cream maybe. And from either side, it'll always be congruent. Okay? So let's do example number 4 with the partner. Go. Say, hi, neighbor. Help me.
But I mean, it's still. What?
So did you set up 3x plus 2 is equal to x plus 8? How many was the x as our clean number? 3.
What?
I didn't.
It never happened. Okay, number 7, put a big star. Let's jump to number 7, everybody. So do I have 2 points of tangency here? I have one here, right angle. I have another one here, right angle. How many right triangles do I have? 2. So when it's overlapped, you have to draw the 2 triangles on the side. So I'm going to draw the bigger one over here and smaller one right underneath it. So on the bigger one, my top side is y plus 12. My side is 10. In the smaller figure, we have the top is 12 and the side is 5. What can I set up after that? A proportion? Yes?
Because they're similar.
Because they're similar, very good. Y plus 12 over 10. So since I started with the y plus 12, I need what on the top? 12. And what on the bottom? 5. Does that mean that is the only way to write the proportion?
No.
Maybe I want to go from like short leg to the long leg is equal to the short leg to the long leg. It really doesn't matter. Now, let's put this in parentheses. Because when I cross multiply, the 5 is going to distribute to the y and the 12. So I'm going to write that out on the side without actually computing at the moment, so we do not make silly mistakes. That's a 5, and that's a y. Okay, let's now distribute. What would that give us?
5y plus 60.
5y plus 60, very good, is 120. And then we have 5y is equal to 60. Then y must be how many? Boom, done. Okay, here's what I do not want you to do. I have seen this on Unit 8. Listen up. I need all eyes on the board. I have seen students do this and go, well, why can't this work? I'm going to show you. I had some kids go y over 12 is equal to 10 over 15, or 10 over 5. If you're doing that, it sounds like it makes sense, but you're really telling me this trapezoid is similar to this triangle, and it is not. So you have to separate it, okay? So moving on to the bottom. Zach, let's read the box on the bottom, please. Boom.
Circles inscribed and a polygon to each side. The polygon is tangent to the circle.
So let's go ahead and draw the arrow from circle to the inscribed. When circle is being inscribed, that means I have a figure and circle is going to go in the inside. What figure or what polygon is the simplest polygon possible? There's one better than that. Triangle. So I want to make myself a triangle. And then what I want you to do is try to make a circle at these 3 points of tangency. It doesn't have to be perfect, and if it is, why not? And then I'm going to emphasize the tangency. Did your circle touch 1 point on each leg? Okay. All right. Our next one says circle is being circumscribed. That means it's going around in a circle as a, more like circumference. So let's go ahead and make, I think I want to do the circle on the outside first. That's easier to draw. Is that a good circle? Pretty good? Now, can I make it so that the triangle goes in the inside? I believe so. So the vertex lies on the circle, vertex here, here, here is on the circle. All right, last one, number 8. Let's try that one with the partner. Talk to your neighbor.
Circle B. Circle B is described in ABC. Did you know that? Alright, AD 6. Okay, so they're on so. Those.
We have 4 different ice cream cones. If that maybe helps. Color coordinating.
How do you know? Those are equal. So it's a parallelogram.
It's not a parallelogram. It is a quadrilateral.
It's quadrilateral.
It's given AD is 6. Thirty more seconds. Nolan. Stop it. If AQ is 3, AZ, or not, A to that point is also 3. And given that AD is 6, Z must be 3. Then that cone has the same part. If that is 2, X must be 2. If that is 4, Y must be 4. So how many is my X again? 2. What about Y?
4.
What about Z?
3.
What about CD?
5.
5. And the whole perimeter must be 24.